we are going to have a look at the ZigZag tasks, and we're on task number 4. This is for AQA Computer Science A-level, and we're looking at the skeleton code in C#. So this is task 4 on the ZigZag list. The question extends the functionality of the skeleton program to introduce difficulty levels to the game. The functionality we need to introduce is easy, medium and hard, and we do this by introducing a list of large numbers, and the application should populate the numbers allowed list as follows. So we pick none of the large numbers. If it's a standard game, we just pick 5 random numbers as it does now. Easy, we will pick one of those large numbers at random and have 4 random numbers for the rest of the numbers allowed. 2 large numbers for medium and 4 large numbers for hard. Okay, so we need to the functionality should produce a brand new set of numbers allowed for each term, even if the user expression does not evaluate to a target. So what we need to do is modify the main method to introduce a menu to give the choice of the type of the standard game that they would like to play, and then we need to modify the fill numbers method and any other methods required to introduce a difficulty level option in the way described. So I've got my blank program here from Visual Studio, and as is good practice, I'm going to start with a new set of code. I've selected it all. I'm going to copy that into Visual Studio. Okay, so first up, we need to go to the main menu. Okay, so we're not interested in the training game. We just need to introduce our menu here. So console console right line, 1 for standard, comma, 2 for easy, 3 for medium, and 4 for hard. And I don't know what I've pressed there. We just need to get rid of that. This always happens when you're recording a video, of course. And we need to put the input into a parameter. Console.readLine. Okay, so that's underlined because we need to convert it to an integer. Of course, because this is reading it in as a string, we need to convert it to an integer. Int 32. Oh, to int 32. Okay. So let's going on here? Ah, yeah, no semicolon. All right. So next up, we need to pass that over to the numbers allowed, because that's where, sorry, to the fill numbers method, because that is where we are going to populate these numbers. So we need to pass over the level to that. And we also need to pass it over to play game as well. Now it's underlined level, and it says, if you can read that, the level does not exist in the current context. So what's happening here is C# does things that other languages let you get away with, basically. I've introduced an integer there in this else branch, but of course, if C#, if for some reason you selected Y as a training game, then level will not be defined as an integer, and it will be passing over a variable there that has effectively not been assigned. So we need to actually declare level up here at the top, and that way it's always going to be declared, and we need to set a value to it too, because that'll be something else it'll complain about if we don't. So that has now made that underline disappear. It has introduced two further errors, and that's because we have not introduced an int level here. So that one's got rid of that underline, and we need to go to the numbers allowed. Go to there. Sorry, fill numbers, I mean. Okay, so again, for the same reason, we need to declare our large numbers here, and we're going to declare a new list. I'm going to cheat by copying that over. I'm relatively new to C# and programming in other languages, so I am just getting to grips with some of the syntax. Okay, so the beauty is with the skeleton code, you may not have a reference guide to the language or to be able to Google things, but you can look elsewhere in the code. So we want a list, and it's going to be integers, and it is going to be called large numbers. Okay, equals new. So I've just looked at that for reference. This also goes for your section B too. If you're not sure, if there's a call for a random function or something like that, and you can't quite remember the syntax for the random, well, you've got all this skeleton code to look at to get syntax from. You've effectively got a kind of a reference guide given to you in the exam for that purpose. Okay, so we have got the list of numbers in. So the next thing is we need to populate those numbers. Oh, not those numbers. 25, 50, 75, 100. Okay. So we need to put those numbers into into the numbers allowed, depending on this level parameter that has been brought in. So new line, we need to generate a random number to select one of those items from the list. Okay, so we need to make numbers allowed equal to a new list as well. So new list of integers. And we need to populate that. So I'm going to use a switch case depending on the option that's passed over. So I think switch and the variable which is level. Okay. Parenthesis. Okay. So case 2 then, and we are going to add to numbers allowed. Dot add, and we are going to add a randomly generated number from large numbers. Okay, and rgen dot next, and we want a number from 0 to 3, 0, 1, 2, 3 from there, so that's 4. Okay, so that should generate a one of these numbers and put it into the numbers allowed list. Okay, so we need the break, then we need case 3, which is the medium level. So we now need, don't forget, if you're not quite sure of this rgen.next, there's plenty of random number generating going on in this program. You can go and have a look for the syntax. So we need 2 of them because we are going to generate for the medium level 2 of these large numbers. We need a break, then we need a case 4, And for the case 4, for the hard level, we are going to generate 4 of those numbers. Okay. So far so good. What happens then, of course, is that the this count will be 2 if we've picked 3, because it will have added 2 of these large numbers already, and it will just finish off by generating the remaining numbers, from this random thing. So that is it, I think. Let's just start and play that. No, we don't want to do that. What are our errors? So there is no argument given for fill numbers. So let's go and have a look at that. Oh, line 71. Okay. Fill numbers level. Control cannot fall out of switch for the final case 4. That means that line 385, we haven't put a break in there, have we? Yeah. Okay. Oh, not bread, break. Okay. So that should be it. What of course we haven't done is put a 1 for the standard game, but that will effectively be the default, and it will drop out of the case and not be selected. What we probably should do is put some kind of validation in the original menu. Probably should do that, but we won't do it for now. Let's just get the game running. So let's go for an easy game. So it's generated the 25. Control that. Let's try again. A medium game has generated 2 hard numbers and populated with the rest. And the hard game has generated 4 of those numbers. Okay, so let's just test the program to see if it does what it is supposed to do. 100, is there yeah, there's a 3. So 75 divided by 25. And it has gotten rid of the 3. It has, in fact, worked. Okay. I kind of wasn't expecting that to work, because there is one more part of the code we probably should look at, which is the maximum number that was passed over to, let's see if we can find it, check valid number. So I would have expected it to fall foul this here, but it hasn't. Okay, I think I've figured out what is going on here. Check valid number doesn't produce an error. So if it's called up within this function here, check numbers used are all in the numbers allowed. So if we go to that function, that method, you'll see here that what's happening within this method is that we are checking to see if the number is valid between, which basically does a range check of these, these two of 0 to maximum number. That's what the check valid number does, and it returns a Boolean value of true or false. If it returns false, it doesn't produce an error. It just doesn't do this. So what is happening is this is basically setting up a temp string to check whether we have used a number, and if we have used a number, it removes it from the temp list so that we then can't use it again. So this is effectively not performing this check and removing it from there, and I can prove that by putting in a write line in here, which is my way of checking. So if I do write line item item removed, and then a plus, and then the item. If that number is greater than 100, it's not going to remove this item. So let's, it's not going to execute this code. So let's just explore that. We'll pick a medium game, and there's a 2 in that list, so I can divide 50 by 25. 50 divided by 25. That write line that I put in has not been executed, and it's removed the number 2. So I could effectively use these numbers twice. I'm going to try it again by dividing 25 by 5 to remove that 5. Now it has removed that 5. So there is an error in this code that you would never have possibly not discovered had I not done this. So I'm going to remove that. Okay. And I'm going to go to the, where am I going to? I'm going to this code here, because we do need to put in some code so that it still returns a true. I'm not quite sure why it does this range check. If it's not in the numbers allowed, it's not in the numbers allowed, unless there's some sneaky exam question that's going to be put in. So I need an OR there. pipe. No. Okay. And I'm gonna I'm gonna create a new list, and I'm gonna copy the syntax from here. And I'm going to put in those values 25, 50, 75, 100, and I'm going to check to see if temp dot contains item as integer. Okay. I of course need to put an extra set of brackets around there. And this time we need to get past those errors. 166. Totally wrong. Let's just check how he set up a list. Okay, it's those brackets. 166, wasn't it? Okay. Empty statement 170. Warning is about. Not quite sure what. Let's go for it. Okay, I've selected a new set of numbers here, and I found another problem with the way this code is, and we'll just look at that now. So I've got 25, and let's see if we can get one of these numbers here. Nothing obvious. Nothing obvious. But let's just try something else. If I divide 75 by 25, it's not removed anything, obviously, but what it hasn't done is refresh those numbers there. So if I go to the coding task, you will see this condition here. The functionality should produce a brand new set of numbers allowed for each turn, even if the user expression does not evaluate to a target. So you can see those sets of numbers are the same. So that makes it even more difficult when you can't find a number to evaluate. And I'm not going to go to great lengths, but it's a bit of a struggle to find a number that's Oh, there is one there. 8 plus 4. Let's try that. 8 plus 4. Now, this time it has given me a new set of numbers. It's removed that 12. And it has given me a new set of numbers. So it's only doing it if I have a successful evaluation. So what I need to do, this is the bit that refreshes the numbers here, okay? And it only happens if you've had a success. And I think I've read that question correctly. This functionality should produce a brand new set of numbers allowed for each turn, even if the user expression does not evaluate to a target. And the reason I say that is I've also looked at the marking scheme for this, and let's just put this here. So this should generate a new set of numbers. But I've even looked at the marking scheme for ZigZag, and the marking scheme has left that in there. I can't see. Okay, so if I enter an invalid expression now, let's go for 75 divided by 50. Okay. It has now given me a new set of numbers for that. But if I look at the marking scheme for ZigZag, that generation of new numbers only takes place within that loop. It's not moved. Whoever's done this marking scheme has not even moved that out. So this marking scheme isn't quite correct from what I can see, unless I've missed something. So that's that one. The other thing was we just need to check that this bit is working, and I probably shouldn't have taken that right line out before, but let's just correct that now, just to make sure that we are executing this piece of code or just proving it. Okay. Number. Oh, item removed. Item removed. Space. Plus. Item. Okay. So this will show that it is removing an item from this list, from this temporary list, so that you can't use it again. So let's give that a go now. 3. Can we evaluate anything here? 50, is there a 10 there? No. Gosh, this really is hard, isn't it? Okay. I think we can get that 33 by going 50 minus 10 minus 7. Okay. So, okay, it has removed it, and it has removed those items now from the from that temporary list, which it wouldn't have done for the numbers greater than the max number. Okay. So a bit of a tough one that. I've discovered a couple of errors in the code, I think, and we've eventually solved this problem. Okay, so that's it for today, and I'll hopefully produce some more stuff for you soon. Bye-bye.